Black holes. The very name conjures images of cosmic monsters, lurking in the dark, waiting to devour anything that strays too close. They are the ultimate villains in the story of the universe, objects of pure destruction from which nothing, not even light, can escape. But what if I told you that much of what we think we know about them is wrong? Today, we're exposing the myths surrounding black holes. Let's start with the biggest misconception of all. Myth. Black holes are cosmic vacuum cleaners roaming the galaxy and sucking up everything in their path. The reality is far less chaotic. A black hole is simply an object with an immense amount of mass packed into an incredibly small space. Its gravitational pull is powerful, yes, but it behaves just like any other massive object in the universe. If we were to magically replace our sun with a black hole of the exact same mass, something incredible would happen. Absolutely nothing. Earth and all the other planets would continue to orbit it just as they do now. We'd freeze, of course, but we wouldn't be sucked in. You have to get very, very close to a black hole for its extreme properties to take effect. They just wait. So they're not space vacuums that chew up planets from afar. But what happens if you do get too close? What if you were to fall into one? Here's what really happens, step by perilous step. Myth. The moment you cross the event horizon, you get sucked in like a smoothie and instantly disappear from existence. It's a quick, merciful end. Reality. Your journey begins by crossing the event horizon, the point of no return. But here's the strange part. For a supermassive black hole, millions or even billions of times the mass of our sun, this moment would be completely uneventful. You wouldn't feel a thing. No jolt, no sudden force, no dramatic transition. You could drift across this invisible boundary without even realizing you've sealed your fate. From your perspective, looking forward, space would look the same. The real drama isn't happening to you just yet. Now, the type of black hole matters immensely. If you were unlucky enough to fall toward a smaller, stellar mass black hole, one just a few times the mass of our sun, your story would be very different, and much shorter. These smaller black holes have an incredibly steep gravitational curve. The difference in gravitational pull between your head and your feet would be enormous, even before you reach the event horizon. This differential is what we call a tidal force. It would grab you and stretch you like taffy in a process scientists cheerfully call spaghettification. You'd be torn apart, atom by atom, before you ever had a chance to see what's inside. So, for any hope of a journey, you need to choose your black hole wisely. Go big, or go home in pieces. But let's assume you've chosen a gentle giant, a supermassive black hole. Before you even reach the event horizon, you'd have to navigate one of the most extreme environments in the cosmos. This is a massive, spinning platter of gas, dust, and shredded stars that have been caught in the black hole's gravity. As this material spirals inward, friction heats it to millions of degrees, causing it to glow brighter than entire galaxies and blast out lethal amounts of radiation. Navigating this cosmic blender would be your first and likely final challenge. And it's not just the disk. Some of that infalling material gets supercharged and funneled by magnetic fields, then shot out from the black hole's poles in colossal jets of particles traveling at nearly the speed of light. These jets can stretch for thousands of light years into space. So, even getting close is a treacherous proposition. But for the sake of our thought experiment, let's say you have a perfect ship and a perfect trajectory. You survive the disk and the jets, and you've just crossed the event horizon of a supermassive black hole. This is where physics gets truly bizarre. According to Einstein's theory of relativity, intense gravity warps space-time itself. For you, falling in, time would seem to pass normally. But for someone watching you from a safe distance, a strange spectacle would unfold. As you approach the event horizon, your image would appear to slow down, getting dimmer and redder, a phenomenon known as gravitational redshift. They would see you frozen in time at the edge of the black hole, your final moment stretched out for an eternity, until your light eventually faded into nothing. Meanwhile, as you look back out at the universe, you would see its future history flash before your eyes at an incredible speed. You'd witness stars being born and dying, galaxies colliding, and perhaps even the end of the universe itself, all in the few moments you have left. Time slows for you, but speeds up for everything else. Myth. Black holes are secret gateways. wormholes that can teleport you to another universe or another point in our own. This is a favorite trope of science fiction, the idea that the singularity is a cosmic subway station. Reality. Once you're inside the event horizon, your fate is sealed, and there's only one direction to go: forward. But forward no longer means a direction in space. Inside a black hole, the roles of space and time are swapped. The singularity, the infinitely dense point at the center, is no longer a place in space. It becomes an inevitability in time. It is your future. Just as you can't stop moving toward tomorrow, you cannot stop moving toward the singularity. All possible paths lead there, and as you get closer, the tidal forces that we discussed earlier, the ones that would have shredded you at a small black hole, now begin to take hold. Even in a supermassive black hole, the gravitational gradient eventually becomes infinitely steep. Spaghettification is inevitable. Your body, your ship, everything you are, would be stretched into a thin stream of fundamental particles. There is no portal, only oblivion. So, that's it, then? You're crushed out of existence, and everything about you, your memories, your experiences, the unique arrangement of your atoms, is gone forever. Myth. Everything that falls into a black hole vanishes forever, without a trace. Reality. This is where we arrive at one of the biggest puzzles in modern physics, the black hole information paradox. A fundamental rule of quantum mechanics is that information can never be truly destroyed. The universe, at its most basic level, should always keep a record, but black holes seem to violate this rule by swallowing information and then, according to the late, great Stephen Hawking, slowly evaporating over trillions of years. They do this through a process called Hawking radiation, where tiny quantum fluctuations at the event horizon cause the black hole to leak energy and mass back out into the universe. But is the information that fell in encoded in this faint radiation? Does it escape? Or is it truly lost forever, forcing us to rewrite the laws of physics? Scientists still fiercely debate this. Some theories suggest the information is stored on the surface of the event horizon like a hologram, while others propose it escapes in subtle ways we don't yet understand. Your physical self may be gone, but the universe might just remember you were there. This all might sound like theoretical fantasy, but we are living in a golden age of black hole discovery. We are no longer just imagining them, we are seeing them. Using the Event Horizon Telescope, a global network of radio dishes, scientists captured the first ever direct image of a black hole's shadow, confirming Einstein's predictions with stunning accuracy. And with instruments like LIGO, we can now detect gravitational waves, ripples in space-time itself, created when two black holes collide hundreds of millions of light years away. We are listening to the echoes of their cosmic dances. These incredible observations are turning science fiction into science fact, allowing us to test these mind-bending theories. So, what happens when you fall into a black hole? The short version. It's not a vacuum cleaner, and it's not a portal. It's a one-way journey into the most extreme physics lab in the universe. A place where time and space break down, where the fundamental laws of reality are pushed to their absolute limit, and where the cosmos keeps its most profound secrets. It's a place of ultimate destruction, but also a place of ultimate mystery. And while you wouldn't survive the trip, the quest to understand it is one of the most exciting journeys in all of science. If you want to explore more of the universe's greatest mysteries with us, be sure to subscribe.